Hello, this video is going to cover 1.4 or 2.7 in the paper textbook. It's curve fitting with a linear model, and what we're going to kind of cover in this one is when you have two sets of data. So for example, maybe your sets of data are height versus weight. How are they related? And that's the idea of this section. How are those related? How can we tell if they're related? And this is the study of regression. It's the statistical study of the relationship between those variables. So it's a regression line that we're looking at. The word correlation is the strength of that relationship between those two things. Well, we know typically the taller you are, the heavier you are. So there's strength in that relationship. And it kind of depends on your data that you collect, right? The line of best fit is the line that you get that fits your data the best. We're only using lines in this section, and we use it to predict. And we're going to find something called the correlation coefficient. So it's represented by a little r. And we're going to, by note, use technology to find. So you have to use technology to find this. The formula for it is really cumbersome. So I'm going to show you how to do it in Excel. You can also use a graphing calculator pretty easily, and you could find a tutorial on how on YouTube or on the web, because I actually don't have a graphing calculator to show you how to do it. So we're going to use a line of best fit to predict things in the future, and we're going to use this correlation coefficient to kind of tell us about our data. So let me show you on my iPad. Hopefully this doesn't glare. No, that looks good. The correlation coefficient, this R. So when we go to plot our data, so for example, if this was our data here, it's forming a line, but they are negatively related because as one gets bigger, the other gets smaller. Okay, so that's a negative relationship, and it's a strong one because it's close to the number 1. So as as we look at this coefficient, our correlation coefficient, it's between -1 and 1, with -1 and 1 being really strong relationship, with 0 being no relationship. So for example, we might do a study on maybe who has the most cars versus oh my goodness, you're grading math or something silly, and you'll get no relationship between them. Okay, so 0 is no relationship, and then -1 would be a negative slope, but really close to a line. So these two here are sort of related. See how the dots are kind of in a line, but you got a lot of outliers. Okay, not related, sort of related, really related, because they're in a line. None of them are ever going to be in a perfect line unless they're an example from your book and someone set it up that way. But if you really collect data and you really form your scatter plot, your dots, you're not going to get this perfect relationship. Okay, so let's do an example. My example that I'm going to use is the average, let's see, the average high of temperatures between these two sets of companies here. So I'm going to move that off and show you what I'm talking about. Right? Was that? Oops. No, I'm not. It was a height one. I'm in the textbook. Which one did I put in my... this was, I was like, I didn't think it was that one. I was close. Okay, so gas mileage and horsepower of a car is the data and the example I'm going to use from the book. Man, that does not, for some reason, that's just not real clear. Maybe if I don't move it for a second. No, it's still not very clear. Okay, so what I'm going to do is when we're given data this way, and it's not super clear, I'm sorry, make a scatter plot of the data with horsepower as the independent variable. Independent variables, again, are your X variables. They're independent. They're on their own. The y variable is dependent on the x. Okay, so in this one the horsepower is going to be our x and our mileage is going to be our y, and it asks us to find the r, the correlation coefficient, and the line of best fit. So you have to be able to come up with an equation of a line and this r, and those are the two things I really want to focus on. So I'm going to use technology. I'm going to use Excel to show you how to do this because it's just better in Excel. So what you're going to do, I'm going to insert a line real quick, is whatever your x values are, you put them here. Whatever your y values are, you put them here. And the x values on this one we had as our horsepower, the mileage. So type them in. Type them in straight down in Excel, straight down in Y, so that all of your dots are linked. And remember, to make a scatter plot, you're going to go over 175 up 22, over 255 up 13. You should have Excel on your computer if you have Microsoft Office, which is required for and on all of our school computers. I tried to use our graphing calculator in the textbook, and you can graph it, but you can't come up with the R, and so that's kind of a hard thing to use. Okay, so what we do from here, once we have our data in, we highlight our data and we go to Insert, and ignore this random number down here, okay? And we're going to go to Scatter Plot, and we want to insert a scatter plot. Notice that I did not put the X and Y in here. I just did the data. Here is a scatter plot. I don't care if I have that word series on there, so I deleted it off. And you can see, like, okay, this data point right here, you can see was over 175 up 22. Change the color scheme. I don't know why it would ask me that in the middle of my recording. So you could see your data points pretty easily, which one's which, see? And those are all, and this is our scatter plot. Well, that does me a lot of good. Yay, I got my scatter plot, but how do I get my equation of my line? Super easy. And how do I do a line of best fit? What you do is you click, left click on a dot, and then right click, add a trend line. We would like to add a linear trend line, and I would like to see the equation on my chart. So close, and there is the equation of that line. This is the line of best fit that it predicts, and there's the equation of it. I'll show you another way to find the equation of your line of best fit, but that is probably the easiest way. And what the calculator in Excel does is it uses something called least squares to find this line of best fit. And it really is something really neat, and a neat method to find the line of best fit. Instead of just throwing up your ruler and hoping you're right and putting it through a bunch of points, which is what most people do, and then finding your equation of your line, this one uses the distance between each point to find the best fit line. Okay, then how do I find my R? There's my equation of my line. What I do is I'm going to go to Formula, and if you want, you could put in like correlation coefficient, and you'll get this one recommended, CORREL. So we push OK. Why does it keep asking me that? And now I have help popping up. Hopefully I didn't download something fun like a virus. So push OK, and it asks for array 1. An array is a list of numbers. It wants your X values in array 1. You could type in A2 to A3, or you could be lazy like me and just highlight them. And then it puts them in for you. And then you push OK, and look, you get your R. This is R, your correlation coefficient. So this is the easiest way to come up with your equation of your line and your correlation coefficient. I am going to show you how to do the equation of the line again from let's just say from two of these points here. So maybe it looks like our line goes through these 2 points the best. So I am going to, I want just to see what point that is. Series 1, there it goes. That one's the point 175.22, and this point here is, it's not telling me. I just want to know what point that is. Huh. All right, silly thing. Keep this color scheme. Do you want to change the? Okay, I don't know why I'm changing the color scheme. Now it's like bright colored. Anyway, I can't get this to tell me what line this one is for some reason. It's about 175, maybe 180, maybe it's 180, 20. That's what it looks like. Okay. So from here, let me bounce over to so you can see what I'm writing. So from here are those 2 points I picked off of that equation, or that graph, okay? So that's where I think the line of best fit went through the best, is these 2 points. How would I then find the equation of the line? So I want to find the equation of the line of best fit. I would first find the slope, and this is something you should really know and remember. So first you'd find the slope. So hang on just a second. I don't want to write on my table with only one paper, or it will make a mark. So remember, the slope is y minus y over x minus x, and on these points the y's are always the second ones. I'm going to do 22 minus 20 over 175 minus 180. That's going to give me 22 minus 20 is 2. 175 minus 80 is -5. So I got a slope of -2/5. And if you want, you can use the decimal, or you can use the fraction. Sometimes a decimal is a little bit easier than the fraction value of that. So let's use -0.4. Okay, and then I'm going to use one of my points. It doesn't matter which one, I'll just use the second one. And you're going to go y minus y1 equals m times x minus x1, and we're going to put in our values into this formula. This was called point slope, and we're going to put in our slope we found and one of our points. So I'm going to use this one, xy. So I would go y minus 20 from the value right here, equals our slope of -0.4 times x minus the x of 180. And then I need to distribute here, and this is the equation, you're done, but I want to make it in a little bit prettier form. So I'm going to distribute that, and I'd have y minus the 20 equals -0.4x, and then -0.4 times 180 is going to give us, oh wait, a negative times a negative is a positive, 72. Okay, now I have to add this 20 over because it's negative, and you have to add it to the end number here. So I'm going to get y equals -0.4x 789 plus 92. So that's our final equation of this line. So what did Excel tell us the equation of the line was? Let's look. So they told us that they had -0.144 and 47. Oh, ours is way different than theirs. It shouldn't be that far off. Maybe I shouldn't have used 180, 20. Anyway, well, I mean, goodness gracious, you're going to get them off. Mine has still got a negative slope. It's still got a positive intercept, but this one's pretty great example I gave. Excuse me. Oh, so So I guess the moral of that one is you got to be really careful which points I use. And maybe I should have just used like this one over here and used like 2, 25, and 15. But anyway, further apart. I know that it's because I used the 2 points really close together, but to my thought was they were the closest ones to being on the line. So you can use technology to get the equation, but I really would like you to be able to do it by hand like I did here, even though mine is a little off. So yours aren't going to be exact answers from the back of the book when you find your equations unless you use technology, which is fine. But you have to know both ways. You have to be able to do it by hand, and you also have to know how to do it on the technology. All right, so then the rest of your questions I think you can answer on your own. So it's going to ask you prediction equation questions, and you take your equation depending on if they give you a value that matches your x. So if it was horsepower, I'd put the value here and times, add, subtract. Or if they gave you a mileage and you wanted to find horsepower, so you could use your equation to predict. Otherwise, this is the main concept. How related are your two variables? And you could tell that by your correlation coefficient. The relationship between these two was really high because it was 0.91. 0.9 is really high relationship. Okay, it's like 91%. It's very high. Okay, so hopefully this video helped you.